So I'm going to try and get into the student view in here. And you can follow along into your own accounts if you prefer, just to look at it. So this is what your interface will look like. So as I was mentioning last time, since we have that 90% requirement on our homework assignments before you can get into quizzes and exams, the way WebAssign does it is you have to do one assignment at a time. So you will first have to start working on section 1.1 homework. You will need to get 90% on that before the 1.2 homework will open up. And same thing as you go all the way down to 1.5. So you have to do one assignment at a time. And then once you have all 5 of these assignments done with the 90%, then the quiz will open up, because the quiz of course is waiting for section 1.5 to have 90% on it. The practice exam, since it's just for a practice, it stays open since it does not count for a grade. But then same thing for the chapter exam, you have to wait till you have 90% on your homework before the chapter exam opens up. And this will be true for all chapters. So since chapters 2 and 3 are grouped together, you will see you will need to work through all of chapter 2 before the chapter 3 assignments will open, and then same thing for the exam and the quiz, and that happens for all the chapters till the end. Additionally, I wanted to show you that you have your textbook available through my ebooks right here at the top banner that you see. So once you click on that, it will automatically show you the textbook for this class, and then you can click on it and access whatever chapter or section, or if you just needed to do some extra practice, all of that will be available right here. So it takes you to your table of contents page. And let's say since we're going to be working on chapter 1 right now, we can click on 1, and with the little menu option here, looks like I may have been looking at this earlier. You can go under the chapter menu, and you can see it's breaking it down by different sections. If you want to go directly to exercises or look at the different information in the chapter, you can go from here. So that's kind of how you access your e-textbook. Again, remember the hard copy is optional. You don't have to purchase the hard copy if you don't need it. And the other thing I again just wanted to remind you guys is just be careful about your attendance, because the attendance is also a requirement to take any of the exams, right? The chapter exam or the final exam. And that's kind of what Natalie was talking about. She didn't want to lose any points for attendance. So just kind of keep that in mind. Also, that attendance plays a big part for this class also. Yeah, Natalie?
So I'm trying to sign in, and I created a profile, but then when I go to put like my email, my password in, it's not working at all.
Oh, okay. Do you have time a little bit after class to hang around, and we can try and troubleshoot this and see what's going on?
Yeah, I can do that.
Yeah, because I may have to look at what your screen looks like and what the message is coming out to be to kind of see why you're having trouble getting in.
Okay.
One thing that I can suggest is sometimes, because the way these browsers work is, they store the old information. So the one thing you can try to do is clear your cache and your cookies in your browser. So just go under, I think, is it under privacy or security? One of those options. Then you can clear the cache and cookies and try again, and sometimes that works. All right, guys. So our first, like I said, today we're starting out with chapter 1. And the first thing we're actually going to be doing is just discussing some basics about logic. So you have this logic handout right here under your class handouts in D2L. You will see the very first one is on logic, which is, our first chapter. But this is just some, examples that you might run across kind of in your everyday, example. So a little bit of a different take. So I'm actually going to open it here in my PDF file that I have here. And so what I want you guys to do is not answer till I ask you to, and you will send your answers through chat. So just have the chat for Zoom open if you like. But when I ask you, only then send your answer, not before that, because I want to give everybody a chance to kind of think about their response and, get ready. And then when like I said, when I ask you, you can send your response in. So we're starting out with just, like I said, some basic puzzles, riddles, those kind of things, because all of these involve, logical thinking. So a very basic shape for a bus. And as you can see, the first question is saying, in which direction is the bus pictured below traveling? So is it traveling to the right or is it traveling to the left? So think about it for just a second. If you want, you can type your answer in the chat, just don't send it. So don't hit enter, just have your answer ready. And I'm going to give you guys just, maybe 30 seconds or something here to think about this. And then when I say, you can hit enter and send your answers through. So in which direction is the bus traveling? And you guys are answering, is it going to the right or is it going to the left? And then we'll talk about why you picked your answer. All right, so make sure you're getting ready to type your answer in. And go ahead and send your answers in, guys. Let's see. Okay, I've got right, neither direction. That's interesting. So I've got right from most of you. Let's see, Brandon, Ashley, Zoe, Logan. Forward was not an option, but okay. We need to know what direction it's going in, right? So I've got maximum of you have gone with right. Ethan, you said neither. It's traveling forward away from our point of view. So Idali, are you saying that we are actually looking at its rear, like the backside, and it's going forward like this?
Yeah, that's what I wanted to say.
That's the first time I have received that answer. That's very interesting. And Wendy, I think you were kind of on the same track as her.
Yeah, that's exactly what I just wanted to type past, and that's all I got. But that's what I was looking to
Okay.
as well.
No problem. All right. And then Cynthia, you are, I think, the only one who has left as the answer. Sandra. And then Idali, looks like you changed your answer to going right. And Natalie, you said it has been stopped. Okay. So those of you who gave me right as your direction, which, of course, right would be, and, of course, since you are also looking at the screen, this would be the right. And then, of course, this is where we're talking about left. So just to kind of clarify what Idali and Wendy were talking about, the bus is actually sideways. So you are not looking at its rear. Because if it was the rear, just imagine, the tires would look a little bit more skinny, right? They would not be looking like these circles. Just kind of imagine when you're standing behind your vehicle, what your tires look like. So that's the reason why we know the bus is not moving forward, going away from us. It has to go in either of the two directions. So those of you who said right, can you give me your reasoning behind why you chose that answer?
I just went with my gut feeling.
Okay, and can you tell me why you had that feeling of moving to the right?
I kind of think it's because I'm right-handed, but I'm not sure.
Okay, that's fine. Roman, you've got this big smile on your face. So I'm going to ask you, what was your reason? Oh, you're on mute.
My reason is just, to me, it's like a question of a matter of perception. So I don't think there's really a wrong answer to this question. I just chose right because I wanted to go right.
You wanted to go right. Okay. All right. And that's a good point that you make. It is definitely our perception that leads us, especially in situations like this where you don't know if there is a right answer or wrong answer. So I will tell you, this is a question that was asked to kindergarten kids. They were doing some kind of a study just to kind of see how adults versus children kind of react to different things. And so this same question was asked to adults and kindergarten kids. And as you can probably imagine, or maybe not, just depending, the adults got it wrong and the kids got it right. And I think a big part of it is, again, coming back to Roman, what he said, our perception changes as we get older and we, our thought process changes. Kids are still very basic. So they have, I guess, in a way, not been polluted by other ideas and other thoughts. So they can actually look at things very clearly. So before I give the answer, I wanted to ask Cynthia, you're the only one who said left. So can you tell me why you picked left?
Honestly, for me, I just thought it was the right way that it's traveling to in my eyes. I don't know.
So you didn't really have any reason more than you just thought it should be going left?
Well, to me, the right side seems like it would be the back of it.
Okay.
And then the left is like the front. So that's also why.
Okay. Okay, so I will tell you, they obviously asked the kids why they picked the direction they did. And the kids said, we do not see the door where you get into the bus. So now think about that. You are seeing windows. You're not seeing a door. So what does that tell you now? Where is the door to this bus? And what direction is the bus heading in? It's going to the left. Isn't that, Logan? I think that's where you're pointing. Yeah, because imagine the door of a bus is always next to the driver in the front. So the door has to be on the other side, which means the driver has to be here, which means your bus is going left. And this is kind of what I was talking about. We have so many different ideas in our head, but we're not looking for the simplest explanation, which is, hey, where's the door? If the door's not facing us, the door's got to be on the other side, which means the bus has to be going left. So that's kind of where, this whole idea of logical thinking comes into play. I mean, there are rules and there are, ways that logical thinking works, but this is just a very, very basic example of how you can use logic in some of these examples. All right, let's go down to our second example here. So this one is talking about the world's tallest skyscraper took 7 years to build. Each year, the workmen were able to double its height. So they want to know how many years did it take for the skyscraper to reach half of its maximum height. So they're telling us the entire skyscraper took 7 years to build. Basically, the workmen were doubling the height every year. So we want to know, when did the skyscraper reach half of its maximum height? In which year? So year 1, 2, 3, 4, 5, 6, or 7. So again, think about your answer, have it ready. Don't send it just yet till I ask you to. Again, I want to give everybody a chance to think about their answer. So look through the information that's given to you. And it's actually interesting. When I first created this handout, Facebook and all other social media was very, very new at that time. So we didn't have a lot of people, using those sources. This handout is at least, I would say, 10 years old. I've made some changes to it over the years, but some of these questions are original. And now I see a lot of these type of questions, kind of show up on, like through memes and whatnot on Facebook and Twitter, and they just kind of want to see how people are thinking about these kind of things. So it's very interesting how these are, just so popular, because you will see like 3,000, 5,000 responses to some of these posts. And it's just amazing So a lot of times I will actually go and read what people are saying and what their explanations are. And it's really interesting to see how everybody has such a different thought process. You know, some people will get really detailed into their explanation, and it always amuses me to see, well, mainly we're all wasting time on social media, but you know, it's just interesting to see how people look at different things. Okay, so if you think you have your answer ready, I'll give you another 30 seconds to just wrap up. You can type your answers in just to keep it ready, but don't send it just yet. All right, guys, go ahead. Send your answers in. All righty. So let's see, I've got. Okay, so we started with 3.5. Roman, you're saying 6. Logan, 3. 3 to 4 or 3.5. Brendan, Zoe, 3.5. Ethan, Ashley, 3. Sandra, you're saying 4. Okay. Nicholas, you went with 6 also. Wendy, 3. 3.5. And then I've got 3. Okay, so again, the question was, it takes 7 years for the entire building to be built. Every year, the height of the building is doubled, right? So think about this. If in the first year they built, and you know, we're just gonna do a basic example here. So in the first year, let's say they built 10 floors. If they are doubling the height, which means in the second year, they will have built 20 floors, but basically the idea is it's 20 floors plus the original 10 that was built. And then they're doubling it again from there. So they should be getting, you know, going on forward from there. So if they did 10 in the first year, 20 in the second year, then of course that would be, 40 plus the original 30 that you already have. So that's kind of how this height will keep growing for this building. So I'm actually going to ask the two of you who had the very different answer from the others, because most everybody has 3 or 4 or 3.5 years. So we have Nicholas, and I think Roman, you were the other one. Yeah, Nicholas and Roman, you were the two who went with 6 years. So I'd like to hear both of you tell me why you picked those answers.
Chose 6 because if they're at half of the height and 6 and they double it, it'd be complete.
Okay, all right. And Roman?
Same logic.
Very nice. You guys should be very proud, because that's exactly what it is. Because if in each year they are doubling its height, so basically the idea is in the 6th year, your building is at half its height, because the next year, the final year when they build it, in the 7th year, they will double that height, right? So if you're at the half point, in the 7th year, you will have the full building created. So again, you know what you guys ended up doing was you just took 7 years and you took its half, right? Because imagine if in the 3rd year, if in the 3rd or the 4th year, or some of you had 3.5, if that's when they built half of the building and each year the height doubles, well, then what were they doing till the 7th year, right? Because if in the 3rd year they had half its height, in the 4th year, they should have had the full building up. So, you know, obviously they had 3 more years that they didn't do anything. So you're not really taking the half of the time. You are just trying to figure out, okay, if in the 7th year the building is full, that means a year before that it's got to be at half its height. And we know that because of this doubling factor that they're talking about over here. So that's kind of how this works. Does that make sense, guys? Okay. All right, so let's try another one here. This one is talking about, and let's get rid of that. Okay, so this one is talking about Wild Bill has played 3 hands of poker in the saloon, each time losing 3/4 of his money. So it's kind of building up on what we just did with the building, but this time he is losing 3/4 of his money. And at the end, he was left with $1.50. So we want to know how much he lost in total. So the way this question works is you kind of have to think about, okay, how much total money he started out with. He's only left with $1.50, and that will help you kind of decide, how much money he has left behind. And then remember, I apologize, guys, the yard folks are here and they're right outside my door, so it's a little bit loud. So they're telling you he has played 3 hands of poker. He is losing 3/4 of his money, and this is what he's left with. We want to know how much he has lost in total. So again, take a minute or two and think about this example. And again, when I ask you to, you can send your answers in, but obviously not just yet. Okay, so again, remember, with each hand of poker he plays, he loses 3/4 of his money. And by the time he got done playing those 3 hands, he was left at the end with $1.50. So you're almost kind of working backwards from there and trying to figure out how much total money he had when he started playing, and of course, how much did he lose by the end of it. Okay, another 30 seconds, guys, and then I'll ask you to send your answer. So just have your answer ready. Don't send it just yet. All right, go ahead, send your answers in. All righty, let's see. I've got $6, $3.75, $7.50, $6.55. He lost $14.50. Okay, $6. Okay, did you guys go all the way back to 3 games that he played? Because to me, it seems like your dollar amount is a little small. $1.55.
So I kind of took it like so like I took 3/4 like literally. So if he played 3 hands of poker, so what I did was I put 75, like 0.75 cents, and then added it to the $1.50 for like 3 rounds, and then subtracted 150 from that. And that's how I got that. But like I said, I'm terrible at math, so I don't know.
So Natalie, it's actually not 3/4 in terms of 75 cents. So it's basically like if he had, let's say he started out with $10, he's actually losing 3/4 of that, which would be $7.50. So they're actually, when they say 3/4, they're technically talking about he's losing 75% of his money. So whatever he's starting out with as he plays the game. I think that's why, yeah, these numbers are coming out to be very small, because if that's kind of what most of you were thinking in terms of dollar amount of 75 cents, then it's going to be too small. Okay, so Roman, you're changing your answer to 22.50. Okay. So let's take a look at this, because this example actually takes a little bit of calculation. So we know he's got $1.50 left. Oops, I didn't mean to do that. Okay, so let's see. He plays 3 hands at poker. So he's got his first, oops. What happened to my... Okay, let's see if this works. This is better. So this is his first hand, then his second hand, and his third one. So let's say the amount he started out with, how much he has lost, and how much he is left behind with. So we know at the end of the third play, he is left behind with $1.50. So we know he's losing 3/4 of his money, right? So we know he is losing 75% of his money, which means whatever is left behind is going to be 25%, right? 1/4 of what he had. So if $1.50 represents the quarter, what would be the 3/4 of that, the amount that he lost? And I know some of you have calculated that, but because you did have the right answer, you just didn't realize that this is only for one play and not the entire 3 hands. So what would be 3/4 if 1/4 is $1.50?
3/4 lost would be 450.
Very nice. Yeah, honestly, you just multiply the $1.50 with 3 times and you will get 450. So in his last play, what did they call him? Wild Bill. He lost $4.50. So when you add that together, this is where you are getting your $6 from. So which means he started his third hand with $6, and that automatically means $6 is what he had left from the previous play, right? So again, working backwards, what will be 3/4 of that $6 he had left? Or, $6 being the quarter amount.
18.
Yeah, 18.
18, yeah, very nice, because again, you're doing 6 times 3. So that would give us $18, and that adds up to a total of, what's that, 1824? And just like that, that means from his first play, he had $24 left behind. So what do you think that 3/4 lost amount is?
72.
Sorry, would you say that again?
72.
72, yeah, very nice. Same thing, multiply by 3. And that's $72. And then, of course, that kind of gives you what he started out with, which would have been the total of that one, which is what, 96? But they're asking us how much did he lose? So we're really only interested in this column over here. And what does this guy add up to?
94.50.
All righty, very nice. So this is what he has lost, is the 94.50. So like I said, this one takes a little bit of a calculation, just because you're having to work backwards and figure out, basically what he started out with. And now you can see he probably should not be playing poker if he's starting out with $96 and leaving with $1.50, which, that would be the story of my life also. So again, you can kind of see how you are again using critical thinking with logic to try and, answer some of these questions over here. All right, let's try one more of these. And this is an interesting one. So this one says, Julie says to her brother Pete, I have as many sisters as brothers. So she has the same number of sisters that she has as brothers. Pete replies, who is also her brother, Pete replies, I have twice as many sisters as I have brothers. So for Julie, the sister, if she has 10 sisters, she has 10 brothers. Pete is saying, I have twice as many sisters as brothers. So Pete, from his perspective, if he has 10 brothers, then he has 20 sisters. And, of course, I'm exaggerating these numbers. So basically, we want to know how many total brothers and sisters are there, or basically how many total siblings are there, if that makes it better. So again, take your time, do some combination of numbers, because from Julie's perspective, she should have the same number of sisters as her brothers. But from Pete's perspective, he has twice as many sisters as brothers. And then give me basically how many girls and how many boys do you think there are in the family? And of course, don't send your answers just yet. Okay, so Julie says same number of sisters as brothers. Pete says twice as many sisters as brothers. So we want to know basically how many sisters and brothers are there. So we basically want to know like how many girls and how many boys are there. So you can do G and B for girls and boys, or you can do S and B for sisters and brothers. It doesn't matter. I'll give you again another 30 seconds, and then let's see what numbers you guys have come up with for the girls and boys. So again, don't send your answer till I ask you to. All right, go ahead. Okay, very interesting. One brother, two sisters. You've got 4 G or S, and I think it was it 2? Let me go back. Yeah, 4 and 2, 4 sisters, 2 brothers, 4 girls, 2 boys, 1 boy, 2 sisters, 2 girls, 1 boy, 2 girls, 4 girls, 2 boys, 1 bro, 2 sis, 2 brothers, 3 sisters. Oh, interesting. 2 girls and 2 boys. Okay. So let's try and break this down. I'll start with the first answer that came through. I think Idali, that was you. You're saying 1 brother and 2 sisters. So from the sister's perspective, this works because if it's 1 brother and 2 sisters, one of those 2 sisters is Julie. So yes, she can say I have the same number of sisters as brothers because that's 1 and 1. But then that actually does not work for Pete because he is saying he has twice as many sisters as brothers, which means technically he definitely has at least 1 brother, right? So that means for Pete, it's got to be 1 brother and 2 sisters. So Idali, you will see why that combination then is short by 1 boy. And looks like Nicholas, you actually had the same answer as Idali. Roman, you went with 4 girls and 2 boys, and Cynthia looks like you have the same one, and I think I saw that with Ashley. Yeah, so let's take a look at what you guys have. So if it's 4 sisters and 2 brothers, then the math doesn't work from Julie's perspective, because if Julie is one of those sisters, there's 3 girls and 2 boys, right? So it's not the same number, not the same, as many brothers as sisters. Now, when you do this from Pete's perspective, that number still don't work, because from Pete's perspective, if he's one of the boys, there's only 1 boy and then 4 girls. So that's a ratio of 1 to 4 and not 1 to 2, right? It should be double the number of sisters. So you will see again, the 4 and the 2 does not work. Okay, Zoe, you've come up with an answer, and I'll get to yours here in a minute. Brandon, you actually had the same answer as Idal. He also. Sandra, looks like you also had the same thing. Logan, same thing. Okay, Ethan, you've got 2 brothers and 3 sisters. Okay, so from Julie's perspective, if she is one of the sisters, then she's got 2 sisters and 2 brothers, so it works for her. From Pete's perspective, if he is one of the brothers, then he's only got 1 brother and 3 sisters, so it's not twice as many, right? It's 1 to 3. So that's where it's not working. And then Zoe, let's take a look at yours, because I think I've answered. Wendy, you also had the same answer, didn't you, as somebody else? Maybe not. Okay, let's take a look at Wendy's answer then. You're saying 2 girls and 2 boys. So if you even just look at this from Julie's perspective, it's not working, because if she is one of the girls, then she only has 1 sister and 2 brothers, right? So that's not the same number of brothers and sisters. And then Zoe, you've got 3 sisters and 4 brothers. Okay, so if Julie is one of the sisters, then there's 2 sisters left behind and 4 brothers. So that's actually, when Julie says she has the same number of sisters and brothers, that relationship actually does not work. And when we reverse it for Pete, that's 3 brothers and 3 sisters. So then it's actually the same from the boy's perspective and not the double. Okay, so Roman, you're actually just switching the number of girls and boys. And this relationship should work from what I'm looking at it, because out of the 4 girls, if one of them is Julie, you're left behind with 3 sisters and 3 brothers. So that's the same number of brothers and sisters from Julie's perspective. If we do from Pete's perspective, that's 3 brothers, so he's one of them. You're left behind with 2 brothers and then 4 sisters, and that's twice as many sisters as brothers. So very nice. Again, you see, you have to kind of work through these numbers. So you should have 4 sisters and 3 brothers for this relationship to work. And like I said, then you can break it down from each perspective, because then Julie is one of the girls. Then she has 3 sisters and 3 brothers. If Pete is one of the boys, then he has 4 sisters and 2 brothers, and you will see how that relationship works out for both of them. All righty, very nice. Okay. So this problem here, you will actually see something similar to this in your homework assignments. I may have actually pulled out from one of, not your textbook, from one of the other ones, but they want to know what is the next letter in the series. So this is your series, and they want to know if you should have L, M, N, O, P, which one of these should be the next letter in these series. So this is actually what we would call as pattern recognition, right? You kind of have to figure out what the pattern of those letters is before you can say what the next letter in the series should be. So you can see you are going Y, Z, V, W, S, T, P, Q. You know, think about what the alphabet looks like. If it helps, go ahead and Google the alphabet so you can see what order they are in. Sometimes, you know, having a visual helps you. I'll give you about a minute to figure this one out. So will your next letter in that series be L, M, N, O, or P? So I'll give you about 30 seconds here. And if you're not sure, just give me your best guess. So don't send your answer just yet. All right, go ahead, guys. I've got N, P, M. I thought I saw another M, N. Okay, so we started out with N, P, M, N, O, M, N, L, M, M, M. Okay. Just looking at the series, I would say by itself, P probably is not going to be an option since that is just, you know, the second to last letter you already have in there. So it's got to be one of the 4 ones. And looks like most of you have gone with M or N. So those of you who picked N for Nancy, can you kind of give me just an idea of why you went with that? If you had a reason why you chose that? Why did you choose N?
I meant to put M.
Okay, you meant to put M. Okay, so
At
Roman,
first, I
what
thought
would
it
you-
was N, but I see it's M now.
Okay,
Because you go from YZ, then you skip X, then it goes VW, you skip U, then ST, skip R, PQ, skip O, and then it would go MN.
very nice. Yeah, so if the sequence, as Brandon wonderfully explained, you're actually going backwards in pairs of 3 and you're skipping, I guess, the third letter. So yeah, you've got YZ, you've got VW. So from the YZ, of course, you know, we're missing X over here. From the VW, you would be missing U. What else did you say?
Can I just say one thing?
Yeah, go ahead.
How come I didn't get that?
Say that one more time.
How come I didn't get that? Literally, I feel so incompetent right now.
Don't feel bad about this because, you know, this is not something you do on a regular basis. So this is not something that's expected of you to just jump at you. Sometimes it just takes a little practice. So please don't feel bad about it at all.
Okay.
So yeah, very nice, guys. So it should be M, and then following that would be N. And then of course, you know, we would skip O because that would be the third letter that's being skipped. So your correct answer was M. And like I said, you know, sometimes if you don't understand, put your best guess in, and you know, sometimes it will work, sometimes it will not. So that's all right. But like I said, this was about pattern recognition. And once you recognize that, it definitely does become a lot easier to move forward from there. Oh, this is a very good question also. So this one is saying, suppose you have a strainer whose measurements are 4 inches in width, 3 inches in height, 6 inches in length. So how much water will it hold? Logan, you also do not need to feel bad because, you know, this is just the idea of kind of what I was talking about. You know, kids recognize a lot of these things so quickly, but adults, because we have so many other things going on, these don't jump out right at you. Especially with these pattern recognitions, it takes me a couple minutes also to figure out what's going on because I don't recognize patterns that easily myself. All right, guys, so just another 30 seconds because this is not a very long question. The measurements are given to you and they're asking you how much water can it hold. So take about 30 seconds and let me see what your answer comes out to be. And obviously don't send it just yet till I ask you to. And this is probably something all of us have tried. if you work in the kitchen, anywhere, you've probably come across the situation. All right, guys, send me your answers. Okay, waiting for answers to come through. Some of you caught on, didn't you? Very nice. Yes, and I think Brendan, you were the first one who said that. It's a strainer, so it's gonna be 0 whatever cubic inches, because the water's gonna strain out. So those of you who came up with 72, you were taking this very literally. Be careful. This was honestly more like a word play than anything else, because they're telling you it's a strainer, so it's going to be 0 cubic inches. Alrighty, very nice. They're talking about the volume of a cube is 27, so they want to know what would be the length if you add up, the length of all its edges. What would that total be? So of course, when we're talking about a cube, what's the one thing we have to keep in mind in terms of dimensions when we're talking about a cube?
They're all the same.
Very nice. Yeah, a cube means all of the faces, and that's going to be 6 faces on that cube are all going to be squares, which means all of these lengths, of course, have to be the same measurement. So really, that's the key when they're talking about, the cube. So the idea is, if your volume is 27, you kind of have to figure out what, the dimension for the cube would be, and then you can find out what the sum of all these lengths will be. So I'll give you guys another minute to try and figure out, if the volume is 27, then what is the measurement for each side of the cube. Okay, another 30 seconds, guys. All right, guys, go ahead, send your answers in. Alrighty, L equals 3. So remember, guys, we want to know the sum of all the lengths of the sides. So I think when you're saying 3, I think you're coming down to just what one side would be, right? We want to know, when you take all those sides and add them together, what that total comes out to be. So I've got Idali with 54, Roman, you've got 9, Zoe, you said 36, Logan 9, Cynthia 4.5, Roman 36, okay. All right, Roman, you've changed your answer, I see that. So that is actually right, because since this is a cube, and the total volume is coming out to be 27, remember, you just did the volume calculation here, which is length times width times height, which means one number multiplied into itself had to give you 27, and that number can only be 3. 3 times 3 is 9, 9 times 3 is 27. So that tells us each single side is, 3 whatever inches, centimeters. They didn't really tell us what that is. So now the idea is, if each side or each edge is 3 units long, if I were to add all of them, what would my total answer come out to be? So can somebody tell me how many sides does this cube have? Yeah, there are 12 sides to each of the faces. I mean, when you add everything up, and just to kind of show you, this will not let me do color, but you've got, 1, 2, 3, and 4 over here, but this 4th side is being shared with the face on the other side. So that's 4. And then you have 5, 6, 7, you've got 8 and 9, and then you calculate the others that are on the back side. So you actually have a total of 12 sides, and then 12 times 3 ends up giving you the total of 36. So the sum comes out to be 36. And Cynthia, you mentioned that these are hard. Honestly, it's because we don't work on these on a regular basis. They seem really hard, but they are not. I mean, think about these. These are everyday objects that we have lying around, or, everyday instances that literally happen around us. We just don't really pay attention to these. Okay, here's another one, guys. If a doctor gives you 3 pills, so he's giving you a total of 3 pills, telling you to take 1 tablet or 1 pill every half hour. Okay, so 3 pills, they're asking you to take it, at a difference of 30 minutes, half hour. So they want to know how many minutes will pass from taking the first pill to the last pill. So, you started, let's say right now you took the first pill, you wait, 30 minutes interval till you take the last pill. So how much total time will have passed from the first to the last pill? So this one, again, I don't think should be that difficult. So I'll give you guys about a minute. Don't send your answers yet. Yeah, Brandon, that's a good question. So Brandon asked me on the cube question that we just did, a cube has 6 sides. So shouldn't it be 12 times 6 instead of 12 times 3? So Brandon, the 3 is actually coming from the measurement, right? Because it's 3 inches or 3 centimeters, whatever. And the 12 is coming from how many of these individual lengths we have. You know what? Let's get into this guy here. I can actually draw a cube over here. Does it not let me do 3D shapes? Okay, I'm not seeing a 3D structure, but let's say this is one of the faces for our cube, and then you will have the sides over here, the top, and then on the back side, of course, you would have this. So the 12 is technically coming from, these sides. So they want to know how many sides. So that's going to be 1, 2, 3, and 4, which is right in the face facing us. Let's say this is 5, 6, and 7. This is 8, 9. This is what's visible to us. And then you have 10, 11, and 12 in the back. So that's 12 total sides, and when we're talking about side, we're talking about this distance. And then remember, each one of that was 3 units, because that's where we had, 3 times 3 times 3, which gave us the 27 as the volume. So that's why we were doing 12 times 3 to get a total length of 36. Brendan, does that make sense?
Yeah, I guess. I mean, because if you're basing it off your faces, there's 6 faces, which each face has 12, so that'd be 12 times 6.
Right, but again, each face does not have 12 sides. The whole cube has 12 sides, right? Because
Okay,
each
yeah,
face-
I see what you mean.
yeah. All righty. Did anybody else have a question on that cube? Okay, so let's come back to our pill and the time it took from the first to the last. So go ahead, send your answers in, guys. All right, Logan, Ashley, Roman, Sandra, you went with 90, okay. Zoe, Wendy 90, Ethan 90, Cynthia 1 hour. Okay, so looks like we're kind of going back and forth between 60 minutes an hour or 90 minutes. Okay, I saw another 60 coming up. 1 hour, 60 minutes, Brendan, okay. All right, so let's just do this with basic, let's say at 9 a.m. we are taking the first pill. Then you wait 30 minutes and we take the second pill. So by that point, okay, Natalie, it will have become 9:30 a.m. So this is when we take the second pill. We wait another 30 minutes and then we take the third pill. So 30 minutes from there is actually going to put you right at 10 a.m., right? So it's really, yeah, like you guys said, only 60 minutes. Because even though you are taking 3 pills, you didn't have to wait for half an hour when you took your first pill, because that was your starting point. So that's why you only have 2 more 30-minute intervals that you have to wait for till you get to the last pill. So yeah, very nice, guys. It's actually only going to be 60 minutes, or like some of you said, 1 hour. Are you guys okay? Who came up with the 90 minutes with this? Okay. Trying to see. Actually, unfortunately, I think those links don't work anymore. I think they've taken those out. So we'll come back to the squares later on. You guys can try and do the squares one on your own, because that is actually something you do in fact see similar questions on Facebook and stuff. So I'm not gonna take too much time on that. But this one over here, number 10, is saying this problem can be solved by preschool children in 5 to 10 minutes, by programmers in an hour, by people with higher education. They're saying, well, see how long it takes you. So you can kind of see, again, this is kind of figuring out because if you add the digits of 8, 8, 0, and 9, they do not add up to 6. So obviously, the value for the numbers is different than what you are seeing. So 8 may stand for, I don't know, 1, 2, 3, 4, 5, 6, anything but 8. Or, you kind of have to figure out, looking at various different patterns, and see what the value of each digit is. So I would start with something like these repeating numbers here and try and figure out what the value of each of these digits is, so that you can then translate into the ones that have mixed numbers in them. Because the ultimate thing is we need to know what value of each of these digits is to know what this answer will come out to be. Yeah, Cynthia, we're just wrapping up with this problem. So I'm just getting you guys started, and then we'll probably have to wait till Friday to finish this problem. Okay. So let's do that, guys. For Friday, go ahead and work on both numbers 9 and 10 and tell me how many squares do you see in number 9, and then we'll try and break down number 10. But if you can come up with the answer in the meantime, that would be great. Again, guys, just please make sure you start working on your homework in WebAssign. Whatever you can do, at least get a head start, and then we'll get into some examples from chapter 1 on Friday. So we'll wrap up with this handout, and we'll get into section 1.1, 1.2, how much ever time we have on Friday. So if you want to stick around and ask me questions, you can do that. Natalie, I'll try and help you out with your WebAssign issue. And then guys, I will see you on Friday morning. So be safe, everyone. Take care and have a great day.
See ya.
See ya.
Thank you.
Bye, guys.
Bye.
I have a good day.
You too. Thank you.
Okay, hang on.
So let me see if I can get you to share your screen with me. Hey, Sandra, I thought your video was not coming on.
No, it was just that I get a little shy on some.
Well, you do need to leave your video on for next class because I will otherwise count you as not attending. So just be careful
Yeah.
for next class. Okay.
Okay,
All right, hon. I'll see you on Friday.
thank you. Bye.
Bye. So
will
Natalie, you
you-
should be able to share your screen with me.
Well, I mean, right now